Hello everyone. We are going to discuss about RSA algorithm. RSA algorithm is developed in the year 1977 by the scientists named Rivers, Shamir and Adalman. This RSA algorithm is named after the first letter of the scientist, and it is a public key cryptographic algorithm in which public key is used for encryption and private key is used for decryption. It is a block cipher algorithm in which a block of plain text is encrypted so that we'll get a block of ciphertext. And here in RSA algorithm, the plain text and ciphertext are integers from 0 to n minus 1, where the value of n is equal to 1024 bits, which is equal to 309 digits. And these are the main steps of RSA algorithm. The first one is key generation, second one is encryption, and the third one is decryption. Here in key generation step, we use to generate the public key and private key. And in encryption, which is the process of converting plain text into ciphertext. Then the third step is decryption. Decryption is the process of converting the ciphertext into plain text. Then we'll see one by one. Next is key generation step. So here the first step is select two prime numbers p and q such that the value of p is not equal to q. Then calculate n, which is equal to p into q. Then calculate pi of n. Pi of n is the Euler-Torsion function and it is equal to p minus 1 into q minus 1. Then the fourth step is select E. E is the public key. Select E such that E is relatively prime to pi of n and the value of E will be less than pi of n. Then calculate the private key D. DE is concurrent to 1 mod pi of n. And here E and n are public key pairs and D and n are private key pair. Next we'll see the encryption process. So here the ciphertext C is equal to ciphertext, M is the plain text and E is the public key. So the formula is ciphertext is equal to M power E mod n. And next the decryption process, it is the process of converting the ciphertext into plain text. So M is the plain text, which is equal to ciphertext power private key mod n. And next we'll see the advantages of RSA algorithm. The first one is highly secure. Since it uses private key and public key for encryption, we'll say that the RSA algorithm is highly secure. And next is it is a public key cryptographic algorithm, which means the encryption is done by using public key and decryption is done by using public key. So the RSA algorithm is widely used for secure communication. And we'll see the disadvantages of RSA algorithm. The first one is slower processing speed. The RSA algorithm has slower processing speed while dealing with a large amount of data. And the second one is larger key size. The size of the key is very large when compared to other algorithms. So the computation, we need more computational resources for storing the key. And the third point is key management. Here in RSA algorithm, we use private key for decryption. So the management, securely managing the private key is necessary for RSA algorithm and it is a tedious process. Next we'll see a problem on RSA algorithm. So the question is perform encryption and decryption using RSA algorithm given P is equal to 7, Q is equal to 11 and the plain text M is equal to 9. So first step is key generation. In key generation, first we have to select the prime numbers P and Q. But here in the problem, the P value is given as 7 and Q value is given as 11, and the value of P is not equal to 7, not equal to Q. And the second step is calculate N. Calculate N. N is equal to P into Q. P value is 7. 7 into 11 is equal to 77. So the third step is calculate Euler's torsion function, which is equal to P minus 1 into Q minus 1. So 7 minus 1 into 11 minus 1, which is equal to 6 into 10, 60. And the fourth step is selection of public key. Selection of public key E. How the value of E will be selected is, the value of E is relatively prime to pi of n, and the value of E will be less than pi of n. E is relatively prime to pi of n and E value should be less than pi of n. So first we'll see what is relatively prime. If you take two numbers 8 and 5, 8 is not a prime number and 5 is a prime number. But here we'll say that 8 and 5 are relatively prime. So we'll see how these two numbers are relatively prime. So find the factors of 8. The factors of 8 is 1, 2, 4 and 8. The factors of 5 is 1 and 5. Relatively prime means the highest common factor is 1. If the highest common factor is 1, we'll say that these two numbers are relatively prime. And we'll take one more example, 15 and 7. The factors of 15 are 1, 3, 5 and 15. The factors of 7 are 1 and 7. 1 is the highest common factor. So we'll say that 15 and 7 are relatively prime. And we'll see one more example, 10 and 5. So the factors of 10 is 1, 2, 5 and 10. Here the factors are 1 and 5. So here the highest common factor is 5. So this is not a relatively prime number. This is not a relatively prime number. Now value of pi of n is, the value of pi of n is 60 and it should be relatively prime with E. So if you take the value of E as 2 relatively prime with 60, no. Next 3 and we'll check with 3 and 60. 3 and 60 are not relatively prime. 4 and 60 not relatively prime. 5 and 60 not relatively prime. 6 and 60 not relatively prime. But 7 and 60 are relatively prime. So we will select the value of E as 7. The value of E is 7 and the value of E is also less than. The value of E should be less than pi of n. 7 is less than 60. So the condition is satisfied. So this is the public key. And next is calculation of private key. Private key D. So the formula is D into E is concurrent to 1 mod pi of n. Now substitute the value of E here. So d into 7 is concurrent to 1 mod pi of n value is 60. And here the value of d will be in the range 1 to 60. The value of d will be in the range 1 to 60. We will substitute the value of d from 1 to 60. Private key d into e is concurrent to 1 mod 60. So substitute the value of d as 1. So 1 into e value is 7. 1 into 7 mod 1 into 7 is concurrent to 1 mod 60. So how this will be calculated is 1 into 7 mod 60 is equal to 7. Actually, if the remainder is 1, then the value of d is equal to 1. But here we get the remainder as 7. So the value of d is not equal to 1. Next, substitute the value of d as 2. So 2 into 7 mod 60, which is equal to 14. So the value of d is not equal to 2. In this way, you have to check up to 60. At some point, that is at 43 into 7 mod 60 is equal to, the remainder is 1. So if the remainder is 1, the value of d is correct and it is equal to 43. So I will show how the value of this mod is calculated. So how this mod will be calculated is 43 into 7 is equal to 301. Actually, we need to find mod 60, but here in calculator we'll divide this number by 60. While dividing this number, we'll get the quotient as 5 and the remainder is after the decimal portion. Actually, we need remainder, so subtract the quotient. So minus 5. This is the remainder, but this remainder is in decimal form. So this will be converted into a whole number. So this will be multiplied with 60. So now we'll get the remainder as 1. Now we have calculated the value of d as 43. So the key generation process is over. The public key is 7 and private key is 43. Now the next step is encryption. So encryption is done with public key. The formula is ciphertext is equal to plain text power e mod n. So here given the plain text is 9. So 9 power 7 mod n is 77. Now I'll explain how this 9 power 7 mod 77 is calculated. So first calculate for 9 power 2 mod 77 and next calculate for 9 power 4 mod 77 and next actually we need to calculate for 9 power 7. So 9 power 7 mod 77 is equal to 9 power 4 into 9 power 2 into 9 power 1 mod 77. Now 9 power 2 mod 77 is equal to 81 mod 77, which is equal to 4. And next is 9 power 4 mod 77, which is equal to 9 power 2 into 9 power 2 mod 77. So 9 power 2 is 4. 9 power 2 is 4. 9 power 2 mod 77 is 4. 9 power 2 7 mod 77 is 4. So 4 4s are 16. 16 mod 77 is equal to 16. And next we'll calculate it for 9 power 7 mod 77, which is 9 power 4. 9 power 4 is 16 and 9 power 2 mod 77 is 4 into 9 mod 77. Calculate it and the answer will be 37. So the answer ciphertext is equal to 37. Next we'll do the decryption process. While doing decryption process, this ciphertext 37 is converted into plain text. So we'll get the answer as 9. So the formula is m is equal to c power d mod n, and c is equal to ciphertext value is equal to 37. 37 power d value is equal to 43 mod 77. How this will be calculated is, we'll split it into smaller units and then calculate. So first do it for 37 power 2 mod 77. Next do it for 37 power 4 mod 77. And next do it for 37 power 8 mod 77. Next do it for 37 power 16 mod 77. And then do it for 37 power 32 mod 77. Next do it for 37 power 40 mod 77. And next actually 30. So next is calculate for 37 power 40 mod 77. Actually 37 power 40 mod 77 is 37 power 32 into 37 power 8 mod 77. Actually we need to find the value of 37 power 43. So next is 37 power 43 mod 77, which is equal to 37 power 40 into 37 power 2 into 37 power 1 mod 77. So in this way we have to split the problem into smaller problems and then calculate. So 37 power 2 mod 77 is 60. And next is 37 power 4 mod 77, which is equal to 37 power 2 into 37 power 2 into mod 77, which is 60 into 60 mod 77, which is equal to 58. In this way you have to calculate for the remaining sub problems here, which is equal to 53, then 37 power 16 mod 77 is equal to 57, then calculate this is 60, and 37 power 40, which is equal to 23. Finally calculate for 37 power 43 mod 77, which is 37 power 40. Here we'll get the answer as 23. 23 into 37 power 2 is 60. 60 into 37 mod 77. We'll get the answer as 9. So here the plain text is equal to 9. So in the decryption process, the ciphertext is converted into plain text and we'll get the answer as 9. So the answer is correct.